my dear learners, I am Dr. Pawan Kumar Shukla, professor at RKGIT Ghaziabad, and as previously I was discussing about the concepts of antenna and wave propagation. The lectures related to sky wave propagation, especially the parameters related to sky wave propagation have already been discussed. Some of the parameters which were associated with each other, I was trying to derive them, I was trying to calculate some of the formulations, some expressions, some derivations for those particular formulas, especially on the basis of critical frequency and maximum usable frequency. I am sure that from the previous lectures of antenna and wave propagation, in which I defined the critical frequency, maximum usable frequency concept, its calculations, definitely you will understand my today's lecture, because the concept of critical frequency, the concept of maximum usable frequency is directly related to the parameters which today I am going to discuss. These are OWF, OWF means optimum working frequency, LUF means lowest usable frequency, and the skip distance which is used in the sky wave propagation. How these parameters are related to each other and how we cannot define one single frequency, one single highest frequency which can be used for the sky wave propagation itself. Why? Why these different frequencies which are ranging differently, which are working differently, where the calculations and the expressions, the derivations, the formulations are entirely different. Basically, in sky wave propagation, the ionospheric conditions, the different other phenomena affect the mode of propagation. So, the different frequencies which are defined for this particular mode of propagation play their roles entirely differently. So, in my today's lecture, I will discuss the frequencies in terms of OWF and LUF for your kind consideration. Let us start with the optimum working frequency. What is this OWF? Obviously, the maximum usable frequency is the highest frequency which can be reflected back to the earth at any incidence. Critical frequency is the highest frequency of the radio signal in sky wave propagation which can be reflected back to the earth at vertical incidence. But OWF, it is the optimum working frequency which actually works in the sky wave propagation, because due to the many reasons, the 15% portion of the maximum usable frequency is minimized, and this is because of the fact that regions, the causes, the ionospheric abnormalities and the different deviations in the ionospheric atmospheric conditions. For the ionospheric propagation, it is really desirable to use a frequency as high as possible. This clearly points out that the frequency used for the ionospheric transmission should be the maximum usable frequency. Every user want to use the maximum usable frequency only in the sky wave propagation, but MUF depends upon the distance between the transmitter and receiver and also upon the state of ionosphere. And it is observed that due to the daily continuous change and irregularities in the ionosphere, the MUF varies about 15% of its maximum value. Hence, practically the frequency used should be 15% less than the value of maximum usable frequency. Generally, the OWF is 50% to 85% of the maximum usable frequency, which we have calculated or derived for the use in skywave propagation. To be able to send signals to a given location, there are likely to be several different paths that can be used. Sometimes it may be possible to use either the E or the different layers, and sometimes a signal may be reflected first of one and then the other. In fact, the picture is rarely as well defined as it may appear from the textbooks. There are some very other kind of theories to define this optimum working frequency. The irregularities, the deviations are the basic cause, because the atmospheric conditions cannot be dealt with our theoretical calculations only. So, simply the optimum working frequency is the frequency which actually takes place and which is the result of the different abnormalities or the different kinds of irregularities. It is observed that the maximum usable frequency at a particular location varies considerably with time of the day, from season to season and from month to month. In this particular diagram, you can see that this is a single region. This is an example of the region. Why it occurs? Because you can see that this is the increase in vertical height during night time. Obviously, when we talk about the height of the ionospheric layer, and for that particular layer from which the signal is reflected back to the earth, generally during the daytime the layers are existing at its specific heights, but during night when ionization level lowers, then the heights of these particular layers are also minimizing, and they are minimized by 10%, 15% or 20%. So, at that particular condition, this condition happens, and when this condition happens, everything is changing, like the distance between the transmitter and receiver, which can be found for that particular same frequency during daytime, it changes during night. When the height changes, the range changes, and the range and height changes, the frequency of the signal is also changing. So, these are some of the effects through which the optimum working frequency comes into the picture. The second point is lowest usable frequency. When the lowest usable frequency is the frequency which would permit acceptable performance of a radio circuit by signal propagation via the ionosphere between given terminals at a given time under specified working conditions. There is a fixed strength of a radio signal, means at the receiving point when we are getting the radio signal reflected back from the ionospheric layer, it must have a particular minimum level of strength, and when this radio signal comes with that particular strength, it is acceptable. Otherwise, this kind of propagation or this mode of radio propagation cannot be considered. So, for this particular region, a particular frequency range is defined, which is known as the lowest usable frequency. Below that frequency level, the radio signal cannot be accepted at the receiving point. So, as the frequency of a transmission is reduced, further reflections from the ionosphere may be needed, and the losses from the D layer increases. These two effects mean that there is a frequency below which radio communication between two stations will be lost. In fact, the lowest usable frequency is defined as the frequency at below which the signal fails below the minimum strength required for a satisfactory reception. It means the signals, the radio signals which are coming after the reflection from the ionospheric region must have a minimum level of strength. There are some other reasons, because the transmission or the communication will be satisfied only when the received signal is having that particular strength. And it is also found that lowest usable frequency actually increases in periods of high solar activities. This is arising because of the increased levels of solar radiations that give rise to higher levels of ionization in the D layer. This in turn increases the level of attenuation introduced by the layer, or especially in the case of D layer, because D layer is the most unstable layer. It is having the lowest ionic density, and obviously, if it is having the lowest level of ionic density, it is most stable, and this is the reason because during daytime it exists and during night it vanishes. So, now we come to a very important parameter in sky wave propagation, which is known as skip distance. Generally, we have already talked about the height, we have talked about the frequency, we have talked about the incident angle, we have talked about the different layers. But till now, we have not discussed the distance, means the range, the distance between a transmitter and receiver, which is actually the most important parameter for an antenna designer, because for establishing a communication link between a transmitter and receiver, it is the most important fundamental parameter as the distance between the source and destination. This is a fundamental parameter. So, now we are talking about the skip distance, why it is known as the skip. As we all know that when we are talking about the different signals which are reflecting back to the earth, obviously some of the signals cannot be reflected back to the earth because of their frequency or because of their incident angle, and when it is done, then you can say that some of the angle, some of the obviously they can be like this, they can be like this, and when the internal reflection, total internal reflection does not take place, then the signal cannot be reflected back to the earth. It means the distance on earth is defined by the incident angle as well as the frequency of the radio signal. These two parameters will define the skip distance, and skip distance is the distance between a transmitter and receiver. You can see here, if we see that this is the skip distance on earth, this is the range, and when we talk about the sky wave, one particular sky wave, a radio signal which is going upward in the ionospheric region and reflected back to the earth after the multiple refractions, the complete distance which is covered by a radio signal is known as the skip distance. So, This is the distance over the earth's surface between the 2 points where a radio signal is transmitted and the point where it is received, having travelled to the ionosphere and been refracted back by the ionosphere. So, simply we can also see that at one particular transmitting end there may be multiple radio signals which are reaching to the ionospheric region and they cover the different distances on the earth. But the first signal which comes back to the earth, the distance between that particular point and the transmitter is known as the skip distance, as you can see here. This is also known as the skip zone. That particular zone is known as the skip zone, means from this particular point to this particular point. As we all know that ground wave propagation cannot take much of the distance on the earth because of its attenuation, ground losses. The distance between a transmitter and receiver cannot exceed more than 500 kilometer, but in the skywave propagation the distance between a transmitter and receiver can exceed 2000 kilometer, or for the highest layer of the ionosphere, means for if the reflection takes place from the F2 layer from the 400 kilometer height in the atmosphere, the range at the earth's surface can exceed 4000 kilometer in a single hop. In a single hop, if the reflection takes place from the F2 layer, the distance can exceed 4000 kilometer in a single hop. So, you can understand the concept of skip distance. It is varying. It is varying because of the incident angle and the frequency of the radio signal. So, the signals leave the antenna and travel away from it, eventually reaching the ionosphere. Normally, they will leave the earth at an angle called the angle of radiation, whether it is low, almost parallel to the earth, or high. At a high angle upwards, they will reach the ionosphere at some point. So, simply when we talk about the skip zone is the distance between the transmitter and the first radio signal which comes back to the earth after the refractions from the ionospheric region. Here the theory of skip zone is generalized, means how the skip distance is dependent upon the angle of incidence. You can see here what is happening. A radio signal is reaching to the ionospheric region at some particular incident angle, but this incident angle is not enough to make the process of total internal reflection at the different heights of ionospheric region. Means when this radio signal is entering with a particular incident angle in the ionospheric region, the process of total internal reflection is not taking place within the range of 50 kilometer to 400 kilometer. Then how ionospheric mode of propagation or skywave propagation can be held? It means what will happen in that case? In that case, that radio signal will leave the ionospheric region without reflecting back to the earth, and the process will be like this. The other signal, it suppose this one, the first signal is coming to the earth, this second signal is coming to the earth. Obviously, the angle of incidence are different for everyone. For this particular case, the angle of incidence is this one, that signal is not coming back to the earth, but this is coming back, this is coming back, but the ranges are different. It means when the angle of incidence is slightly high, obviously the range at the earth surface can also be extended. These are some of the calculations. Obviously, the calculations of escape distance is also very important part, because the designer, the simply we can say the whole phenomena of radio communication is defined for the calculations of these parameters only. So, in the region of radius less than d skip, it is not possible to establish a communication link by the waves reflected from the ionosphere. These are very important concepts. If we talk about the calculation of skip distance, this is as much as similar as the calculations of maximum usable frequency. What is happening here? Simply we see that this is the case of flat earth. Flat earth means the distance between the transmitter and receiver is not very much high. It is not more than 500 kilometer. So, the earth can be considered as flat surface, and when it is flat, then this kind of phenomena occurs. Means this is the ionospheric region, this is the earth surface, this is the transmitter and this is the receiver, this is the radio signal which is reaching to the ionospheric region, and this is the reflected signal. So, this is the angle of incidence, and by using the same formula we can derive the distance, we can derive the formula, we can derive the expression for this particular distance, because this is the skip distance d. And how we can get this formula like this: f MUF is equal to f c into under root 1 plus d square upon 4 h square, as we have already discussed in the case of maximum usable frequency by using the Snell's law or by using the formula of refractive index of the ionospheric region. This is the same formula as you have already discussed, like mu is equal to under root 1 minus 81 n upon f square. Obviously, you have put the different values of critical frequency and MUF. So, by using this formula, when f MUF is equal to f c into under root 1 plus d square upon 4 h square, all the expressions, all the angles, all the values remain same as in the case of maximum usable frequency, only you have to derive the expression for d here, and for this d you formulate analysis, calculations are done like this, and finally, you get the answer like this, that d square is equal to 4 h square bracket f MUF upon f c whole square minus 1. So, d skip is equal to twice of h under root f MUF upon f c r whole square minus 1. This is very important formula, and you have to remember this formula for the different calculations and for deriving the expressions also. This can also be dealt how the when we are talking about the height, means from that particular point through which the reflection takes place, and the different formulas for this for the calculation of this virtual height. This is also a parameter which is equally important as skip distance and maximum usable frequency or critical frequency. But at the same time, the calculation of virtual height is based on the time constraint through which one radio signal is going upward and coming downward. At that particular time in which it travels both the distances is given as time t, and when this time t is given, the distance, the height is may be calculated, and in the same way it can be given as d skip is equal to twice of h under root f mvf upon fc whole square minus 1. So, these are some of the formulations which are very important in the calculation of skip distance. So, my dear learners, I hope that you are getting all the understandings related to these parameters, because numerical problems, calculations, derivations, expressions, all are very important. So, thank you very much for watching this video. In my next video lectures, definitely I will give some more information related to the radio wave propagation. Thank you very much.